Hello everyone. In this video, let's talk about number 15.3 in section 5.6. First, let's analyze the structure of the functions. Notice that there are two possibilities to make the denominator to be 0. X equal to 0 or x equals 1. Moreover, we consider the domain or the lower and upper bound of the integration, which is 1 to 2. Then 0 is actually outside the point, outside the interval. So we don't really need to worry about that. Now for x equal to 1, this is the left end point of the interval. That means the function actually is singular at this point. And according to the definition of the improper integral, we should understand the integral as the limit. Okay? What we can do is we replace the lower limit by a number a. A is slightly greater than a, greater than 1, right? And we take the limit as a approach to 1 from the right-hand side, all right? This is the definition part. Now, let's work on the integrand. It seems that we can apply the partial fractions to simplify this. Okay, so there are two unknown constants, a and b. We can use the common denominator techniques on the right-hand side and compare both sides and solve the constant a and b. Turns out to be -1 and 1. And then we can continue. Since we had already separated those two terms, the antiderivative are in the type of natural log. Okay, then we plug in the data. Also here we could utilize the property of the log functions, and then we obtain something like this. Finally, let's just plug in the number 1 or take the limit. All right, now we will see here a minus 1 divided by a. This will approach to 0 plus. By natural log of 0 plus, this will give us negative infinity according to the image of the natural log functions. Minus minus, we will recover positive infinity. Okay, so this will be the answer to this question. A quick recap. We first analyze the function, identify the singularity. In this particular case, the singularity is on the left end point. Then utilize the definition of the improper integral, write this one as a limit, one-side limit. Okay. Also, we apply the partial fraction technique to further simplify the integrand such that we can figure out the antiderivative. Okay. Finally, we take the limit as a approach to +1 and get the answer that we want. All right. So thanks for watching.